For the experiment described below, let X determine a random variable and use knowledge of probability to prepare a probability distribution. Two names are drawn from a hat, signifying who should go pick up pizza. 6 of the names are on the swim team and 4 are not. The number of swimmers selected is counted. We're going to complete the probability distribution below, and then we're given this table where the X row has a 0, 1, and 2 in it, and P of X has 3 blanks that we will fill in, and we're told to round to 4 decimal places as needed. First, let's talk about what exactly is a probability distribution. It's going to be a table that lists all the outcomes with the corresponding probabilities, and the sum of those probabilities must always equal 1. So in this case, the probability of X is going to be equal to the probability of X equals 0 plus the probability of X equals 1 plus the probability of X equals 2, which must be equal to 1 or very close to. So how do we go about finding these particular probabilities? Well, we're going to have to go back to the original problem, and we're going to have to look at it and understand a few things about it. First off, we're going to start with 2 names are drawn from a hat. That means that there are going to be 2 persons going to pick up the pizza. 6 of the names are on the swim team. So that means swim team, there are 6 names. And then 4 are not. So we'll just say not swim or just not. So there are 4 names. And now what we need to do is understand that there are different combinations that happen here. We'll start by constructing a tree diagram for drawing the 2 names. And then once we've created the tree diagram, we will use the product rule for independent events to calculate the probability for those events. So we note that there are 2 possibilities when I first draw. And that's going to be that the person is either on the swim team or they're not on the swim team. In order to calculate the probability of that, we need to know first off what the total number of people are in this group, which in this case will be 10 names. So that means if the first name that I draw is on the swim team, that is going to be a probability of 6 out of 10. And yes, I can simplify that, but I'm going to wait for a moment. In addition, if I draw a name that's not on the swim team, that's going to be 4 out of 10 because we are looking at it as independent events and we're looking at it into specific groups. The next thing is once I draw this name that happens to be on the swim team, there's no replacement. So once that name is drawn, that means there's only 5 names remaining on the swim team. So I've drawn my first name. Let's say that they were on the swim team, and now I'm going to draw my second name. They are either going to be on the swim team or they're not going to be on the swim team. However, if they are on the swim team, remember there are 5 people left and there's on the swim team, and there's a total of 9 people left. For not being on the swim team, it's going to be 4 out of 9 because there are still 4 names that are not on the swim team, but now there's only 9 names remaining. We're going to use that same logic down here when we talk about what happens if the first name that I draw is not on the swim team. Well, once again, I now know that they're either going to be on the swim team or not on the swim team. If they are on the swim team, and I drew a name that was not on the swim team to start with, there's still 6 names on the swim team, but now there are only 9 people left in the group. Likewise, if they're not on the swim team, I now only have 3 people remaining that are not on the swim team, but once again, I'm down to 9 individuals in the entire group. And now, as I said, we're going to use the product rule for independent events to calculate the probabilities of all of these. Now, as I said, we're going to use the product rule for finding the probability for independent events. And we're going to have actual 4 events here. The first one is going to be, you can draw the first name, and it's going to be on the swim team. And you can draw the second name and also on the swim team. Another way of writing that would be the intersection of these 2 independent events. Either way, we're going to use the product rule, and the probability of both names being from the swim team is going to be the probability of drawing the first name on the swim team times the probability of drawing the second name. And it's also on the swim team. And then we go ahead and calculate this, which will reduce down to 1/3, which, as we're going to round to 4 decimal places, will simply be 0.3333. And we're going to do that for the remaining 3 probabilities, remembering that we can write them as the first name being on the swim team, which would be right here, and then the second name not being on the swim team, which means that it'll be the probability of S sub 1 N sub 2, and that will be equal to 6/10 times 4/9, and that'll be equal to 4/15, which, when we divide that out, will be equal to 0.26 repeating, or rounded to 4 decimal places, 0.2667. Now, the probability when the first name is not on the swim team and the second name is on the swim team will be the same as the one that I just calculated, because you'll notice that you have 4/10 here and 6/9 there. And we'll round to 4 decimal places there. And then finally, there's going to be the fact that the first name is not on the swim team and the second name is not on the swim team, which means the probability of this particular intersection will be equal to 4/10 times 3/9, which will be equal to 2/15, which will be approximately equal to, and these should have been approximately's up here, since we are rounding, 0.1667. And now what we're going to do is we're going to take those 4 probabilities, we will add them together, and we'll end up, or not add them together, we will put those probabilities in place. Now, I apologize, I said 0.1667, and this should actually be 0.1333. Alright, so moving on. What we're going to do is we're going to complete the probability distribution. So what we want to do is we want to actually determine what the probability of x being equal to 0 is, which means there are no names from the swim team. So we'll write that down here, no swim team. And that's going to be this one right here. So it's 0.1333. Then the next one is going to be the probability that x is equal to 1, which is going to be equivalent to 1 swim team name. And we actually have 2 of those, which are right here, so we'll need to add those together or multiply by 2. And we have 0.5334. And then there's going to be 2 swim team names, and that's going to be your probability that x is equal to 2, and that's going to be this one up here because there are 2 swim team names, and that's 0.3333. Now, we do need to verify that this is actually a probability distribution, so we want to go ahead and add these 4 together and make sure that we get 1. So 3 plus 4 plus 3 is going to be 10. carry that 1. 1 plus 9 is 10. Carry that 1. We get the same thing. Carry that 1, and we have 9 plus 1 is 10. And so yes, probability distribution. So to complete the table so that it looks exactly like what you need to fill in, we'll have x and p of x. And in the first column, our x will be equal to 1. And that p of x is, not 1, 0. And that's going to be 0.1333. Then we're going to have p of x is equal to 1, and that's 0.5334. And then p of x equals 2, and that's going to be 0.3333. And so now we have our probability distribution table.